Okay, I want to show you a new feature for Cube Designer today. It's a feature called Optimize Cube. It can be found on the Cube Designer ribbon under Admin Tasks, and there's an Optimize Cube. What Optimize Cube's going to allow you to do, it's a set of utilities that's going to allow you to optimize the performance of your hybrid BSO cube. It is BSO only. It does not work with ASO. And it's designed to help you optimize using the new hybrid feature of Essbase. So as part of Cube Designer, it's only going to work with your DBX workbooks. So you would export a DBX workbook from your Essbase 21C application, and it would download into this format. If I right click here, you can see it's got all the different worksheets of the cube. It has the dimensions, it has settings sheet, and with the optimized cube you're going to want to add any calculation sheets and query sheets that you want to test. And only one thing to note is only include the calculation sheets that you want to execute. The optimized cube utility will execute every calc sheet in the workbook. So if you have extra calc sheets that you don't want executed, you need to remove them for this exercise. The other thing to note is in the cube.settings, I'm not sure if everyone knows this, but you can set the application CFG from within the DBX workbook. And what I like to do is I like to get all the pertinent properties that may impact various things like loading, calcing, and querying, and I like to set them in this workbook so that I can adjust them and retest. It's just a nice way to work on your cube. All of these settings are the defaults, and I'm not going to go through every one of them, but you notice there's caches of various types. The in-place data write margin percent. This is the block buffering in 21C, where we make the block 20% bigger to reduce fragmentation. You can adjust that down to 0. You can make it larger. See how that impacts your cube sizes. And this long query time threshold is for logging the queries and getting a bunch of information out of the queries. So let's go to the optimization utility. So this is an actual customer application. It was a traditional BSO cube, and the first thing we did was turn every upper level sparse parent into dynamic, just to see what the performance would be, whether we could totally make the cube dynamic without having any calculation scripts at all. This is the output screen. I call it a dashboard. This is the output screen of the utility we call the baseline utility. And what it's going to allow you to do is create a baseline of statistics to start from, and then monitor those statistics as you apply changes or adjust configuration settings and so on and so forth. So let's look at what this dashboard has. On the left hand side, it's going to show you the size of the data files that you loaded and tested. In this case it was a 145 megabyte file. How many input cells were loaded? So 15.5 million cells. The size of the block, and again the block is determined by what dimensions you have defined as dense. And it's going to show you the cache settings. Obviously there's a lot more settings, but these are more the important settings for the cube. So as you make each run, you'll be able to tell what were the settings for that run. So that's the left hand side. This next section just is a snapshot of how the cube is designed, and you'll see that there are tooltip or cell notes on each of these dimensions. It'll tell you whether it's a dense dimension, a sparse dimension with all dynamic, This red is a sparse dimension with dynamic formulas, and that's important. It shows you the order, the sizes, and such. The next sections we're going to track the load, actually the cube build and load time. So in this case, it was 90 seconds to build the cube from this DBX workbook and load that 140 megabyte file. This cube doesn't have any calc scripts. If there were, they would be listed after the initial data load. And we're tracking how many blocks and how big the page and index files are for the cube. Next section is the query section. Again, if we just have one query in this test. If you had multiple, you could you would have them listed here, and they'd run one after the other. And finally, we're going to optionally test the export time and size. As you tweak your cube, the export file size and the time can be impacted. So these are all very important items when I optimize cubes from customers. These are all the different things that I look at when I'm making changes to a cube. You really have to take a holistic view of optimization. You can't just optimize for load or calc and not worry about query and export. So this is kind of the dashboard that I use when I optimize cubes. Okay, so in this particular case, the red flag for this cube after turning the sparse dimensions to fully dynamic is you can see the query time is almost 10 minutes, 594 seconds. It's reading an awful lot of blocks, and it's executing a tremendous number of dynamic formulas, almost 10 million dynamic formulas. There is a white paper that I wrote a couple of years ago on hybrid optimization techniques and what to look for. In this case, the culprit is this dynamic sparse formula. One of the rules, the cardinal rules of hybrid optimization is unless you absolutely have to execute a dynamic formula in a sparse dimension, you always want to execute those at the end of all processing. And in this case, you can tell that there are sparse dimensions that need to be aggregated, especially this large entity dimension needs to be dynamically aggregated after the sparse formula. And what that does is it causes this actual formula to get executed on every base member of this large dimension, and that's why there are so many blocks and so many formulas getting executed. So what this utility is going to allow you to do, so let's go fix this. The way to fix this is to set the solve order of the offending member in the DBX workbook page. And actually, let's look at one other utility real quick that'll also clarify this. If we go to optimize cube, first it's going to make me log in, so let's log in. Okay, so these are the optimized cube utilities. We're talking about the baseline right now, but one of the nice utilities here is this solve order button. If I click on the solve order button, it's going to interrogate all of the worksheets in this workbook, and it's going to build a grid of exactly how Essbase is going to execute on a dynamic query. And so it's going to show you the dimensions and solve orders for those dimensions. It'll also find all the formulas that are being dynamically executed. So here is the offending formula. You can see it's being calculated the fourth item by the calc engine or by the query engine, but then it's also having to aggregate the hierarchies for these other sparse dimensions. So that's the issue. So what we want to do is come in and set the solve order for this member name called FBVAR, and we want to set it so that it happens after the attributes. And actually I'm going to set it to 101 so that it is the last thing that executes. So let's go to the scenario dimension. Right click here, and you can see this FB var. It's a very simple formula, but it doesn't matter the complexity in this case because it's making the query engine grab too many blocks. So all you do is in the solve order column you would set it to 101. Okay, and we'll go back to our baseline. We'll save the workbook, and the way you re-execute is you go to Optimize Cube, say Create Baseline. Actually, I'm going to, under the Customize button, by default we don't test the export size, but I'm going to go ahead and test that. What's nice also is you can run these in individual sections. So if you don't want to run the calc scripts over and over, you just want to test queries, you can do that by unchecking the others. But I'm going to run all of these. I'm going to click the baseline, and it's going to ask me where what data file you would like to use with this. I'm going to click Add. You can multi-select and load more than one. I just have one data file. The other key thing to note is all your data files need to be located on the Essbase server, so within the catalog itself. I like to create folders under shared and put the data files for testing. That way when the cubes get destroyed and recreated, the data files don't have to be re-uploaded. So I put them under the shared folder. I could put it under my own user folder as well. Okay, so that's the data file. We click OK. The first thing it's going to do is it's going to recreate the cube based on the worksheet, the sheets in this workbook. So it's going to adjust that scenario solve order this time. So it's building the cube and it's loading the 140 megabyte data file, and we'll wait. It's going to step through each of those four categories that we saw under the Customize button. Okay, the data file is done loading. So now it's loading the 140 megabyte data file. It's done with that. It's now going to run the query sheet that's in this workbook. And remember, the original query took 594 seconds. You'll get this message if you've run this this query on a different server. It's going to say I need to set it to this new connection, so that's why you would get that. Just hit OK. And that'll only come up one time. If you keep using the same server, you wouldn't get that message, but I've been testing different servers, so that's why I got that message. You just hit OK. And now the query is running. It seems like the query is still slower than I like it, but we'll check the statistics once it's done. So the query's done, and now it's running the export, and we'll see. I think the export took about 20 seconds originally, so we'll see if there's any impact. There shouldn't be. And the export is done, and its final message is baseline generated. So you just go ahead and close. And what's nice about this is it'll build your dashboard for you. So it's going to keep the original information, and it's going to put a second set of information right below it. So we can see that All of this information is the same. We didn't adjust any caches or anything. The data load in calc is the same as well, same number of blocks. Okay, so the queries itself, by changing the solve order on that one formula, the query went from 600 seconds down to 30 seconds. It's still longer than what I'd like. It's still asking for almost 500,000 blocks, and so we can rectify that. So the next technique that I'm going to apply, so we fixed the formulas, and actually if we go to the solve order, I can rerun this as well. So let's rerun the solve order. It's also going to create a new dashboard setting, and you can see FB var used to be a solve order of 10. Now FB var is at the bottom with a solve order of 101, and that's why we went from 600 seconds to 30. The next thing we need to do is reduce what I call the data intensity. We're going to reduce the number of blocks that are being required by the sparse dynamic calculations. And the way you do that is it's similar to the ASO aggregate view concept, where we want to pre-calculate some upper level blocks so that they're already created and they don't have to dynamically get read at query time. And the way you do that in BSO is you pick a dimension and you calculate and store it. And typically I'll take the largest dimension, so in this case entity. I'm going to remove the dynamic upper level calculations. I'm going to create a calculation script and I'm going to execute it. So let's go to the entity worksheet, and you can see that under storage there's an X. What's nice about Excel is I can just delete all these X's, and a blank storage cell means to store it. So I'm going to get rid of all of these X's. There's 16,000 members in this dimension. Just hit delete. Okay, so that's gonna make this dimension execute as stored. The next thing I need to do is create a calculation sheet. And what's nice about Cube Designer, if I go to Designer Panel and I click the From Sheet button, it's going to read all the sheets and populate all the information. But there's a Calc tab here, and I'm just going to create a new Calc script sheet. Just give it a name. Click To Sheet. And now if I look in my worksheets, I see there's a new sheet called calc.entity. And I'm going to just write a real simple calc script. And I'm going to say calc dim entity. Okay, hit enter. I'm going to say yes, execute this. Let's say yes. And I'm going to save this worksheet, or this workbook. Okay, so now I've removed the upper level dynamic calculations. I've created a calculation sheet. I'm going to go ahead and say optimize cube again. Let's run the export, see how that changes. Say create baseline. I'm going to add that same data file, and away it goes. So we'll wait and have it create the cube. It does destroy the old cube and recreates the new cube. So we're not creating many cubes out there. It's just destroying and creating the same cube, just with different settings. So it's creating the outline now. Outlines, the cube is built. Now it's loading the data. it is loaded. It's now running the calc script. And again, it will run more than one script if you have multiple scripts, if you want to test a flow. In this case, we're just calculating one dimension. And that calc script's done. And now it's going to rerun the query. And hopefully it will be much faster. And the query's done, and now it's exporting. And I would expect this export to take a little longer and the file to be a little bit bigger, since we're calculating and storing the large dimension. So we'll see what that statistic looks like once this is done. Alright, everything's done. So let's go look at the results. So before we calculated and stored the entity dimension, our query was 33 seconds. We're now sub-second, which is exactly what I would want. All Essbase queries should be executed in under a second usually. So we'll see, we'll go from left to right. We'll see that the entity dimension now has a blue color. This means it's a sparse dimension that is calculated and stored. So orange is dynamic, red is dynamic with the formula, blue is calculated and stored. Okay, and so you can see the load time was about the same. The script took 35 seconds. So we had a query that took 33 seconds. So for waiting 35 seconds to calculate one dimension, our queries went from 33 seconds to under a second. So in my opinion, it's worth the 30 seconds of calc time to get the optimized performance on the queries. And you can see the number of blocks that were required went from 400,000 down to 275 blocks with 88 formulas. The export doubled in time and the size doubled, and that's because we calculated and stored this sparse dimension. So this is kind of the flow. It's not always exactly this flow, but those are two of the most common optimizations in hybrid in the hybrid BSO cube. Is either solve orders. If your query performances are poor, you either have a solve order issue or you have a data intensity issue. You're asking for too many blocks from the query, and they're very simple fixes. You saw just setting the solve order on one member and calculating just one dimension just with a simple calc solved the optimization for this particular item. One of the things that is also included in this utility, this optimization cube utilities, is a utility that will help you identify what the calc cache should be. So if you are going to calculate a dimension, what should the proper calculator cache be for that dimension? And so we've added a utility under Optimize Cube called Calc Cache. If I click on that, it's going to show you what the cache should be set to in order for the dimension that you're calculating to get to be able to utilize the calculator cache. I'm not going to get into this. It's a whole topic of how the calculator cache is calculated, and There's a whole process of moving dimensions around, but you can see that the calculator cache should be set to 2K. The default calculator cache is 200K, so we could lower this down to 2K and save memory. Setting the calc cache too high can degrade performance. In this case, this cube is small enough that it really wouldn't impact. 35 seconds is fine. But if you need to optimize the calculating of the one dimension and you want to super optimize it, you would run the calc cache utility, set this to only as large as it needs to be, and you would also in your calc script, you would probably use a fixed parallelize the script, normal calc optimization things that I'm not going to get into today, but and then you would make the changes, rerun your baseline, and you'd be able to see. So what I like about this utility is it documents the process. It documents what you've done. A lot of times when you work on cubes, you forget what settings you've used and so on and so forth. So number one, it's a great documentation feature. I would use this on every single cube, just so you have some documentation of how it used to run at a point in time, because we all know that as new versions of Essbase come out, or if you move from one set of hardware to another, you want things to be equal or better when you move to those either new versions of software or new versions of hardware, and this is a great tool to help you document that. The other utility that's included is what we call data distribution tool. This is a tool that you would use either to reimagine your existing cubes, or if you're building a new cube. One of the things that you as an Essbase designer want to be cognizant of is the block size in a BSO cube. And the key to having a great running Essbase cube is to define the block correctly, and the block should have the densest dimensions contained within it, usually. So what this utility is going to let you do is it's going to interrogate the data set that you want to feed the cube, and tell you by dimension how is the data distributed. And the way we do this is we set one dimension to be the only dense dimension, and since we know how many cells have been loaded in total, the number of blocks that get created when that dimension is set as the only dense dimension tells us the average number of cells per block, and that's a density measure. So on average, there are 14 cells in the account dimension that have data. On average, there are 6.79 cells, or 7 cells, for that period dimension. So these are the more dense dimensions, and it makes more sense to make them dense in the cube. It's not always the case, but this is great information not only for setting the block, but for also if you are using fixed parallel, you want to parallelize on a higher density sparse dimension, because then you have less empty tasks being run. So this is a great tool for helping you define the block. It's a great tool for helping you choose which dimension to use in your fixed parallel task definition. So again, there are four different tools. The baseline tool creates that great dashboard. Data distribution tool will tell you how the data is distributed amongst your dimensions. Solve order, again, will interrogate all of the flow within that cube and give you a visual of exactly how the dynamic calculation query flow is going to be executed. And then the calc cache is for identifying the smallest calc cache that would suffice for your calculation. So 4 great tools. I would highly recommend getting to know this tool, the Optimize Cube tool within Cube Designer. I think every Essbase admin should put this in their toolkit.